Stop working. I took off some purple just to warm it. Stop working just to start it. I took off some purple just to warm it. Stop working just to start it. I took off some purple just to warm it. Stop working just to start it. I took off some purple. I got stop working just to start it.
What's up, everybody? I am not a software engineer, but today we're going to talk about building a Python script that will help us to brute force 12-word seeds, such as the ones that you would see when creating a MetaMask wallet. So what I have here is a giant list of words, and this list of words contains, I want to say, tens of thousands of common words in the English language. And I think there's even some somewhat offensive words in here. Just full disclosure, rename this. I'm just going to call it, I guess, word list. So I'll just do a move and then word list.text. And we can actually close this in the background here. I kind of look through this list, and I'd like to get a Python file, which is kind of what we're going to be using to generate the very bare bones script. Can we read from it, and can we print each line? In order to do that, I can just do with open additional new lines or something like that, but we're going to just run it and see what happens, what we would expect. So it's going through line by line. It's getting line by line through this list, and then right here, for example, wolf. At 5, right? Populated at this point, so I can just 2,294 words, right? And the reason I do random is just because I don't want to get like the first 2,294 words, because that wouldn't be a list in and of themselves. So I'm going to call choices, and I'm going to create that a new list, right? I'm going to have it be 4s, 5s less, 6s less, and 7s less. So then what I'm going to do is variable name, I think. So now I'm going to have word choice equals random.choice word length 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there you go. There is an example of a seed that resembles something you would see.
Cool, now it iterates forever. And look, you can see it changing all the words. And it looks like one worked. So let's see this wallet. Let's hope it has some money in there. Your private key on MetaMask is stored with a permutation of 12 random letters from this list of 2,048 letters, supposedly. Suppose you created a MetaMask wallet and this was your seed word here, these first 12 words. Let's say you stored these seed words on a piece of paper, but you felt like it wasn't secure enough. So to increase your security, you did the following. You took the 12 words and you randomized their order and stored them on one piece of paper. On a second piece of paper, you stored the key to the actual order of the words. For example, notice that above corresponds to the 5th word in the sequence, above. So in order to unlock your MetaMask wallet using the seed phrase, you would need to have access to both pages. If you just had access to one page, for example, page 2, you would have no idea what to do. And if you just had access to page 1, you would know the combination of words required, but you wouldn't know the exact permutation. How many possible permutations are there if you had the 12 words, but you didn't know their order? 12 factorial, which is 479 million different combinations. Suppose you lost your second page. I'm going to try to brute force all the permutations of a 12-word seed phrase. To start, we're going to import these 5 libraries, and you have to make sure that you have Selenium installed on your computer. Next, we're going to define the seed words in a dictionary. The order here doesn't matter since we don't know the correct order. All right, next you're going to go to your Chrome and you're going to install MetaMask here. And once you have MetaMask installed, you want to go to type in Chrome extensions like this. Chrome : / extensions. And you should see your MetaMask wallet here. If you click on developer mode and details, you will see the ID right here. So go to your file explorer, and this is where it is for me. If you go to users, my account, make sure your hidden folders are shown. Go to app data, local, Google, Chrome, user data, default, extensions, and you should be able to match your Chrome ID here to the folder ID right here. Copy this file path and click pack extension. And we're going to finish the file path inside this folder. 10.12.1_0. 10.12.1_0. Pack extension. Now it already exists, but if it doesn't exist, it will create this CRX file here. Once you have the CRX file, we can define our path here. This path is the exact path to the CRX file that we just created. Now we want to define our options for our WebDriver. We do that in the following. We add the extension of the path and we define the driver. If we run this file here, it should open up a Chrome file and open up MetaMask. It takes a second to load. And there we go. So now we open MetaMask using our Chrome WebDriver. Now, despite the fact that the WebDriver will open to this MetaMask page, when you try to click a button, I believe it has this tab open instead. So you need to switch to the current tab. The way you switch to the current tab in the program is with this line of code right here. Switch tabs. Driver.switch_to.window and then the current window. Next, we need to click the Get Started. To clip, and we put the string. Now we want to paste that in the keys to the element we just clicked on using keys.control + V, which is a paste function. And that will paste what we copied to clipboard here above. Then we sleep. All right, let's use the WebDriver to enter one singular seed phrase, but we want to enter all the permutations. So basically it will return the next highest number using, let's do a random password. Let's print before. All right, there's about 100. And we'll let it run for a couple hundred. All right, so it took 15 seconds to get from 100 to 300. So that's 200 divided by 15. So it does about 13 a second. So let's pause this and do some math. Program.
The Zeus virus, often called Zbot, is a form of malware that targets your desktop and mobile devices. It has become one of the most successful pieces of malware in the world, afflicting millions of devices. Moreover, the virus continues to generate new variants, spawning on new hosts and expanding its reach. The Zeus virus can infiltrate your device in two ways. Firstly, it can come in the form of a link within an email. There have also been social media campaigns designed to spread the malware through messages and posts. Secondly, hackers can insert the malicious code onto legitimate websites, compromising any user that visits, whether through a corrupt link or a compromised website. Once the Zeus virus installs itself onto your device, it can perform two serious actions. Firstly, it forms part of a botnet, which is a network of corrupted machines controlled by the malware's owner. The botnet allows the owner to collect massive amounts of information and execute large-scale attacks. Secondly, the malware can act as a financial services Trojan that steals banking credentials. Through website monitoring and key logging, the Zeus virus recognizes when a user is on a banking website and steals the keystrokes used when logging in. There are three effective measures you can take to shield yourself from the Zeus virus. Firstly, employ safe internet practices. Avoid potentially dangerous websites, like those offering illegal free software, adult material, or illegal downloads. Do not click on unexpected links within emails or social media messages. Secondly, ensure safe interaction with financial institutions while online. Two-factor authentication, where the website sends a confirmation code to a mobile device to confirm the login, is a must. However, be aware that there is an Android version of Zeus called Zitmo, short for Zeus in the Mobile, which is designed to capture one-time passcodes that some banks use for two-factor authentication. Therefore, to effectively protect online banking transactions from these sophisticated viruses, a safe money solution should be used. Finally, to detect whenever the Zeus virus is present, scan for and remove the virus if already infected, and provide an adaptive layer of security. A powerful and updated internet security solution must be used.
Hey guys, welcome to the next engineering attacks. Inbuilt to assist and select application, Kali Linux, and over here you will find the spear phishing attack. So I'll just go ahead and select one and I'll hit engineering it by using the harvester. I believe I showed you previously about the harvester. I may check if I have taught you that. Yep. And by doing this you will gather information about the harvester. As of now, I've stopped it because my attack is an random for few engineers. We want to leave. We would be leaving these on the listeners' victims' machine lawyers. So same. And that's the name, and you can. It was in the root, so I'll just. I had Adobe Reader installed the victim, and I'll name it something as
Hello everyone, Zaid from Z Security here, and in today's video I'm going to show you how to easily and quickly create Trojans. A Trojan is a file that looks and behaves like an
In this video, I want to show you how you can anonymize Windows 10 traffic using the Honix gateway. Windows 10 PC, please take a look in the description at the video that I made earlier that will explain in details how to install this. So here, after you have Honix and VirtualBox installed on your Windows 10 PC, you need to install Windows 10 in VirtualBox environment and reroute its traffic through the Honix gateway. To do this, we traffic through VirtualBox. If you don't have a Windows 10 ISO, stick with me and I'm gonna show you how we are going to download it. So open your click on the download tool now. This step here takes around back when the download finishes. So the setup finishes. And simply click on Insert Guest Addition CD Image. And now the CD image is inserted. The IPv4 of Windows 10 here to reroute the traffic through the Honix gateway. So I'm gonna switch to VirtualBox, and you see here that I already started the Honix gateway and the Honix workstation. So let's switch first to the Honix gateway. It is here. So this is Honix gateway. We need to get the IP configuration from it. Open the terminal window and key in /sbin/if config and hit enter. And you see here under Ethernet 1, this is the IPv4 of the gateway, and this is the subnet mask, and this here also will be the default gateway. So keep it open. Let me put it here. And let's switch now to the workstation. And we need to switch to the workstation just to make sure that we don't give the same IP address of the workstation to Windows 10. Otherwise, we'll have an IP conflict if we are running the three machines, all of them together. So here simply let me get the IP address of the workstation as I did for the gateway. And you see here that the workstation is taking the IP address of 10.152.152.11. So now we don't need the workstation anymore. And we know that we can give for the Windows 10 machine any IP that is 10.152.152.12, 13, 14, 15, any of these. The important thing is that it should be under the subnet, and under Ethernet, click on Properties. And for IP assignment, click on Edit. Click. Remember that 2.10. And here we are connected to the network now. So let's start leak test. And this test will show us where our IP address is being rerouted. And you see here that I have like a complete different IP address than the one that my ISP gave me. So click on standard test here. And you see that my IP is being rerouted through the United States. So let's just open here any website. Let's open MSN just to show you that the internet is working. And now we are browsing the web anonymously through Windows 10. Just remember that to access the internet from your Windows 10 machine, the Honix gateway should always be running. So that was it. I hope you enjoyed this video and found it useful. If you did, please share it, subscribe to my channel, and give this video a thumbs up. Thank you all for watching.
Hey guys, Hackersploit here, back again with another video, and in this video we're going to be looking at how to set up Honix. We're going to be taking a look at the Honix gateway and the Honix workstation as well as
Oh, drat these computers. They're so naughty and so complex. I could pinch them.
What's up, everyone, and welcome. In this episode, we're going to talk about the Ragnar Locker ransomware. How attackers infiltrate their newest publicly announced victim, which is the Capcom company out of Japan, how they were able to execute the ransomware attack, and how we can protect ourselves and our clients from these types of attacks. Before we jump into the nitty-gritty, let's talk about the agenda. The first thing I'm going to do is give you a definition about ransomware. In order to build a good defense, we must intimately know our enemy. I want to make sure that everybody is on the same page in terms of what ransomware is defined as. Once we have that out of the way, we'll jump right into what is Ragnar Locker, how does it work. If we know the pieces and how they work, we can evaluate whether we are vulnerable and then shore up that vulnerability. We want to learn from the fallen, who has been attacked. We're going to review some notable companies affected and see if we can learn anything from their experience. Finally, we're going to wrap it up with what can I do? Steps to improve. We're going to look at some common areas that we can immediately address to reduce our vulnerabilities. So, what is ransomware? According to Wikipedia, ransomware is a type of malware from cryptovirology that threatens to publish the victim's data or perpetually block access to it unless a ransom is paid. While some simple ransomware may lock the system so that it's not difficult for a knowledgeable person to reverse, more advanced malware uses a technique called cryptoviral extortion. That would be the Ragnar Locker ransomware or ransomware group. So it encrypts the victim's files, making them inaccessible, and demands a ransom payment to then decrypt them. In a properly implemented cryptoviral extortion attack, recovering the files without the decryption key is an intractable problem. Big problem. And difficult to trace digital currencies such as PaySafeCard or Bitcoin and other cryptocurrencies are used for the ransoms, which makes tracing and prosecuting the perpetrators also difficult. Ransomware attacks are typically carried out using a Trojan disguised as some legitimate file that the user is tricked into downloading or opening when it arrives as kind of email attachment. I say typically because there are other ways in which you can get infiltrated, and we will discuss those very shortly. So, what is the Ragnar Locker, and how does it work? So Ragnar Locker is an evolving ransomware. Some sources actually say it's the ransomware gang. There is a Ragnar Locker ransomware gang that employs ransomware attacks. Nevertheless, it affects devices that are running the Microsoft Windows operating system. It was initially observed towards the end of December 2019 as part of a series of attacks against compromised networks. So first, the attackers, they infiltrate your network and do recon to find out if there's anything even worth stealing. This might actually be kind of how they determine the price that you want you to pay. So if you have like massive financial data for them to take or huge databases filled with in-depth customer data, passports, and all kinds of stuff, it could make it a pretty expensive ransom. So once the attackers have completed their recon and they've taken any data that they want, they deploy their ransomware payload, which encrypts the entire network. So anyone connected with any Windows device to the network has their device encrypted, and then finally you get this ransom note, which includes like how you can pay. Well, that's a very brief overview. We're gonna dive pretty deep into this ransomware to see how it works. Let's first go through the steps I just outlined in the next sort of layer of depth. So the infiltration step. The attackers first compromise networks, infrastructures, and organizations using found vulnerabilities, or they go through social engineering such as phishing or spear phishing, business email compromise, or BEC attacks. Now, in the case of Capcom, they had either an old VPN device or the software was outdated and had a vulnerability in it, and that's how they got compromised. So it wasn't due to phishing, it was actually due to an infrastructure vulnerability. So after they do the infiltration, they basically, sit on the couch, order some pizzas, get all the gang together, and they begin their recon. Pre-deployment tasks and data exfiltration are performed before they execute the piece of ransomware. In the case of Capcom, the attackers, in terms of their ransom data. They got 10 gigabytes worth of data, including customer information. Doesn't sound like a lot, but in total you're looking about 350,000 records and sales data, and when you break that down, there's something like 1,400 employees and maybe 150,000 people from this website that Capcom owns, and then there was something related to people who either sent their resumes and that information was stored. But the entire amount is estimated at roughly 350,000 people that were affected. So once the recon is done and the pre-processes are set up, the payload is dropped, which then is executed manually. So again, these people haven't left yet. They're still inside your network after all this time, hours, days, weeks. They then execute the ransomware, they encrypt the entire network, and then you see a ransom note. So here's just a snippet of one of the ransom notes. What's key here is that each malware sample is unique, with the specific ransom note hard-coded inside the malware. The affected group name, the links to the Bitcoin wallet, and the links to a dark web blog are embedded inside the binary. So this is a pretty heavy manual process. There are humans involved at most of these steps. So it's not like a script kiddie or something that just runs automatically. There is time, a massive amount of time and effort involved to learn about your network, what services are running, and get a sort of a map out of what they need to do in order to then encrypt everything as much as possible to increase the damage. So let's take a look at the infiltration step, just so we can, for ourselves, think about it. Well, how could they get in? There are numerous ways. If you have a VPN with the COVID, there have been so many people that are working from home, but they still may need access to stuff in the office. So you have a VPN set up. They connect. You have to make sure that that's up to date. That is, again, how Capcom was infected. They got through via a vulnerable VPN. The next, RDP, remote desktop, another way to connect inside of a network or control another computer would be with the Windows RDP software. FTP, let's say you allow either your users or some kind of customer an FTP access for them to upload any type of files that you may need for projects or for your own work. If you have a web server that you're hosting internally for anything from your own company's website to development environments for your clients, if you're in a type of agency, or if you've seen any of my other videos, like hosting your own Gitea or hosting your own Jenkins server, those are all things that allow access from outside your network into your own network. Then there's the mail and phishing, which is the typical way of delivering these infected malware packages, or at least infiltrating the network. And then there are other backdoors, like other software that you may be running that itself can get infected. Now there's the CodeCov Bash uploader tool. I also did a video on that hack. The SolarWinds hack. I haven't yet done a video on the SolarWinds hack because it's just a massive thing there. But it's coming out soon. So you can see here that attackers they don't just need to rely on phishing. They have multiple points where you could potentially be vulnerable here. So how does it work? Once they actually get the infiltration, they're going to install virtual machines on any infected local machines. And this is key. This is a key piece of information that you're going to want to be on the lookout for. Maybe build some scripts or services that check on a regular basis if any of these types of files have been added to your system. That way you can be alerted and disconnect that particular machine immediately, like create another script, PowerShell script, to just disconnect it from the internet completely, if this were to be the case. That's an option. So we are now at the recon level. They've infiltrated, and they're basically, like I said, ordered pizza, calling all the buddies to come in, and they're mapping out your network. They're finding out what services you have running, database services, network drives, file shares, domain controllers. They're looking for valuable assets. They're looking for trade secrets. They're looking for any financial data they can get their hands on. They're looking for databases filled with customer data. They're looking for information, again, by Capcom. If I remember correctly, it stated that it was people who had applied for a job and had information that Capcom was still holding on to. That was also grabbed. Once they have those assets, they're looking for anything they can use to as leverage to make you pay, make you want to pay. They then upload that to a secure server, and while that exfiltration is happening, files, etc. So, in order to truly understand all of this, recent information kind of leaves out a lot of important information, I feel. So I went back to as far as I could, and I went back to May 2020 when the Sophos Labs did their report about the Ragnar Locker ransomware. And the key there is that it actually installs a virtual machine. And this virtual machine is the key to how they have circumvented so much of existing security. So this is what we need to pay attention to. Now the payload was a 122 megabyte installer with a 282 megabyte Oracle VirtualBox Windows XP virtual machine. So in past attacks, the Ragnar Locker group used exploits of managed service providers or attacks on Windows Remote Desktop, RDP, which we mentioned already, connections to gain a foothold on the targeted networks. After gaining administrator-level access to the domain of a target and exfiltration of data, basically stealing all the data they're going to use for the ransom, they used native Windows administrative tools such as PowerShell and Windows Group Policy Objects, GPOs, to move laterally across the network to Windows clients and servers. Now, I say laterally across the network. That doesn't just mean an office. If you're thinking just about inside your office, you're crazy. These things move across countries, wherever the network leads it. So, in the detected attack, the Ragnar Locker actors used a GPO task to execute a Microsoft installer, the MSI exec.exe. It passed parameters to download and silently install this 122 megabyte crafted unsigned MSI package from some remote web server. The primary contents of the MSI package were a working installation of an old Oracle VirtualBox hypervisor from Sun XVM VirtualBox before Sun was bought by Oracle in 2010. Then a virtual disk image file, a VDI, named micro.vdi. So if we could create a service to scan on changes or scan our system regularly for a micro VDI, that's going to be an important piece for us to deter or to catch it early. So an image of the stripped down version of the micro VDI is an image of the stripped down version of a Windows XP Service Pack 3 operating system called Micro XP 0.82. The image includes this 49 kilobyte Ragnar Locker ransomware executable. So the entire Ragnar Locker ransomware executable is 49 kilobytes. What do these guys do? They infiltrate your network. They drop a VM, right? Or they use an MSI exe, exec.exe, to call to download and silently install this VM. The VM is installed, the VM is started, and then on that VM is this 49 kilobyte executable. So the virtualization software and the virtual disk image are copied to the folder C Program Files 86 Virtual Appliances. So if I could monitor my systems, my Windows-based systems, I would be monitoring for any creation or any change within that directory. I'm giving you all the answers. So, in addition to the VirtualBox files, the MSI also deploys an executable called va.exe, a batch file named install.bat, and a few support files. So after completing the installation, the MSI installer executes the va.exe, so it's executed now, which in turn runs the install batch script. And the script's first task is to register and run the necessary VirtualBox application extensions, VBoxC DLL, VBoxRT DLL, and the VBoxDrive.sys file, as you can see here in these individual batch file commands. So now the VirtualBox is registered and can be run. The script then goes on to stop the Windows Shell hardware detection service to disable the Windows autoplate notification functionality using this command, scstop shell HW for hardware detection. Next, the script executes a command to delete the targeted PC's volume shadow copies. It's a real kick in the nuts right there. So victims cannot restore old unencrypted versions of their files. Now the install bat script then goes on to enumerate all local disks, connected removable drives, and mapped network drives on the physical machine it's installed on. So its host. so they can be configured to be accessed from within the virtual machine. So you have your physical, let's call it a laptop. On that laptop is now a virtual machine, and that virtual machine is now gaining access to any device that this physical machine now has access using this script. So the commands of like where the locations are of your C drive, your E drive, any external drives, any file shares or network drives, that's stored in a list. And then in order to construct the micro XML VirtualBox configuration file for when it boots up and then has access to all this stuff, they basically use this script here to take the VM1.txt, which, if I'm not mistaken, was the drives. They give it a CPU count, basically give it the configuration. The total configuration of the virtual machine is 256 megabytes of RAM, 1 CPU, and a single 299 megabyte hard drive file micro VDI. Then they add on an Intel Pro 1000 network adapter that's attached to the NAT. So now the virtual environment is prepared, right? They set up their virtual environment. The install.bat command goes through a list of processes, names, and terminates these processes, so any files they have open are unlocked and become accessible for encryption. Think about a database. When a database software is running, those files are essentially locked. They would not be able to be encrypted. But if I stop the database server, those files are just files, and they are accessible, and I can encrypt them. So the list of 50 entries consists of mainly line of business applications database, as I just mentioned, remote management and backup applications. So backup applications are then stopped so that the backups themselves can be encrypted, and it is stored in a text file. Another text file contains service names. These are tailored to the victim organization's network environment. So again, this is not all automated. A lot of this is manual. A lot of this is people infiltrating your network, sitting there for hours, days, weeks, learning how your network is set up, how far it goes, to which countries, from India to China to America to Germany, wherever, and they are they're looking at all the processes that run within those networks so that they can tailor this attack to your environment. So the processes that are included and the names, to like endpoint protection software, there's SQL, there's Sophos, there's backup, LogMe, LogMeIn, ConnectWise, etc., etc., etc. So with the environment now properly prepared, the install.bat script starts the virtual machine with one command. So up until this point, it's pretty much all been recon and prep work. Now this one command is what kicks everything off and gets, after this, you're in trouble. So below is in this screenshot here that I got from Sophos is an illustration of the installation process that was captured by the Sophos Intercept X. I got this from the Sophos website. You can see here, where's my mouse? You can see here, step 1 is the MSI EXE. That's basically downloading the VM, setting up the VM. And then you have process 2, process 3 here, process 4, registering services, they're mounting volumes. Process 6, there's some stuff that's cut off here because I reduced the size of it, but these are all things that happen, like find exe, essentially find out either services or find connected drives. This run DL32 exe. There's just tons of stuff that is happening once this virtual machine gets started. So the following steps can be identified in the root cause